Lesson 10, Reading 1. What happens to atoms and molecules when I see different processes? Getting ready. If you had a glass of clear water and you poured red drink powder in it, the liquid would turn red. Did a chemical reaction occur? The following questions will help you think about whether this is a chemical reaction. Embedded text-dependent question. 1. What observations could be evidence that a chemical reaction occurred? 2. What must happen to the atoms and molecules of the substances for this to be a chemical reaction? This reading will help you think about whether mixing drink powder and water results in a chemical reaction or not. After the reading, you will look at these two questions again to see if you have any new ideas. Do atoms always rearrange? A can of soda fizzes when you open it, but that is not a chemical reaction. When you boil water, it bubbles, but that is not a chemical reaction. You learned in Lesson 6 that bubbles might be evidence that a chemical reaction occurred. These are two examples of when bubbles can fool you. How can you tell when a chemical reaction results in new substances and when substances are mixing, but not changing into new substances? Two different things can happen when you mix substances together. 1. The atoms arrange in new ways to create new substances. This is a chemical reaction. 2. The atoms and molecules do not rearrange. They do not interact chemically to create new substances. Early in this unit, you read about chocolate milk as an example of a mixture. It might be helpful to reread those pages to help you understand the difference between chemical reactions and mixtures. In that example, the atoms and molecules in the chocolate and the milk all stay next to each other in the glass, but they do not break apart and recombine. Another example, salt water. When you put a little salt in a glass of water, do you create a mixture or start a chemical reaction? You end up with salt water. Is that a new substance? Water is a substance. It is made of H2O molecules all the way through. Salt is a substance made of NaCl, sodium chloride, all the way through. When you add salt to water, the substances do not interact with each other to form new substances. The atoms from water do not rearrange with salt atoms. Instead, think about the atoms of salt as sitting together next to the water molecules. In the following graphic, you can see how the atoms from the salt are all around the water molecules. Imagine even more of those atoms around the water molecules. This is what happens in a mixture of substances. A mixture is made of two or more substances. Salt water is a mixture. No new substances are created. Each substance can also be separated from the other substances. If you left the glass of salt water on a shelf, the water would evaporate, but there would still be salt in the glass. The atoms in the salt and the water do not rearrange to form new substances. They just sit next to each other in a mixture. Remember that a glass of salt water or chocolate milk has billions and billions of atoms in it, so they are far too small for you to see. Only diagrams or models of mixtures like the previous diagram can help you understand what it means for particles to sit next to each other in a mixture. You could do this saltwater investigation at home. First, pour some salt in the palm of your hand and taste it. Salt has a very distinct taste. Now pour the salt from your hand into a drinking glass. Add some water and stir. Add enough water to dissolve the salt in the glass. But if you add a small rather than a large amount of water, this investigation will not take as long. Leave the glass in a safe place until the water has evaporated. Taste the substance left in the glass. You will be able to taste for yourself that what is left is the same substance you started with, salt. Remember, never to taste anything in the lab or that you mix at home unless you know for sure that the materials you are using are safe. Otherwise, tasting can be very dangerous. This activity is another fun way to think about how atoms and molecules behave in a mixture that you can see for yourself. You will need a glass, cup, or jar filled with water and another container with some extra water in it. You will also need some sugar. Set the filled glass of water on the table or a countertop. Use your cup of extra water to add even more water to it. Add as much water as you can so that the water rises above the top of the glass a bit. You want the glass to be so full of water it will not hold another drop. Embedded text-dependent question. Predict what will happen when you add a bit of sugar to the water. Now, take a pinch of sugar, or a little bit in a spoon, and very slowly add the sugar to the water in the cup without touching the spoon to the cup or to the water. Do not stir. Even though you quit filling the cup with water because you thought it could not hold another drop, it should hold more sugar without spilling. Slowly add another pinch or spoonful of sugar and see what happens. Keep adding sugar a little at a time until you cannot add any more. You know that the sugar is dissolving in the water, but what does dissolving mean in terms of the molecules in the water and the sugar? The water in the cup is in a liquid phase, which means there are microscopic spaces between the molecules. When you add sugar to the water, the sugar molecules fill in the tiny spaces between the water molecules. You cannot see these spaces, but you can tell that they are there. You can keep adding sugar until the spaces have been filled. Sugar molecules fill the holes and sit next to the water molecules. You might do this activity with a parent, relative, or friend and predict what will happen. Explain to the person with you what is happening. He or she might agree that it is quite amazing. Comparing phase changes, mixtures, and chemical reactions. The following chart is one way to organize what you have learned about the differences among phase changes, mixtures, and chemical reactions. Use what you know about phase changes, mixtures, and chemical reactions to answer the following question. Embedded text-dependent question. Which of these is a chemical reaction? A, freezing water. B, melting fat. C, making hot chocolate. D, making bread. Circle 1 and tell why it is a chemical reaction. Be as detailed as you can. Choose any one, A, B, C, or D, of the others and tell whether it is a phase change or a mixture. Be as detailed as you can.